Welcome to a lesson with Dr. Powell. Let's take a look at the function y is equal to x cubed minus 3x plus 5. And let's look at derivative information for this function and see how it helps us to graph it. Does it help us at all? Well, let's look. Let's take the derivatives. Y prime is 3x squared minus 3. The second derivative is 6x. So what does the first derivative tell us about the function? Well, it tells us what the slopes are of the tangent line, kind of like the slope of the function. This is like the slope of the slope. Let's start out with this first derivative and see what it can tell us. Let's look at its graph. So this is like 3 times x squared minus 1, or x minus 1, x plus 1. And if we think about the graph, it has an x-intercept at -1 and an x-intercept at 1. And behavior is like the leading term 3x squared, so up, up, or like a parabola. It goes like this. Let's look and see what this means when the y values here are positive. What does that mean? That means that the slope, so this is kind of like, if you want, you can kind of like label slope here. So you can remember that the y values talk about slope. So when we're right here, you go up here and the slope, so at this x value, the slope on the function is going to be positive. It's going to be positive. So what does positive slope mean? We better draw a little diagram to help. So when on an interval where it's positive, we should think about where the slope is positive, we should actually draw a positive slope. So we draw a positive slope right here up until it ends right there with an arrow going up. Now, what about over here? Looks like the y value is negative, and the output of the derivative talks about slope. Negative, what does negative slope mean? That means you're decreasing, going down. So we can draw an arrow going down, but we should draw this arrow all the way until we stop right there being negative, all the way up to it. Then from there, positive derivative output means a positive slope, so we draw a little picture like this. So we can think the original function will follow a pattern like that. It'll be increasing and then decreasing and then increasing again, following the slopes that we see from this picture. So we can kind of get a sense that our function is going to be looking like something like this, increasing and then decreasing and then increasing again. Notice how you have like a peak here and a minimum here, and we got that right where it changed from increasing, decreasing, and then decreasing, increasing. Right at those pivotal changes, we actually got a maximum and a minimum. All right, so what is this what point is this? Let's see. Well, we know the x value here is -1, but this is a point on the original function, right? So we can get what that point is on the original function by just plugging in that x value. So we plug in -1 here, and we see we get -1 and +3 plus 5, we get +7. Okay, now for here, this is where we plug in the x value of 1. So we plug in 1 into the original function, we get 1 plus 5 is 6 minus 3, we get 3. We have a lot of good data about this graph. Look at that, it's kind of nice. Now, let's see if the second derivative could give us any more data. Well, maybe at first it doesn't quite when we graph it. See, its graph of 6x just looks like this. If we look at this, this is like slope of slope. So this is positive, which means the derivative is increasing. And you'll notice it is increasing from here to here. Notice it's kind of has an upward thing, like all the tangent lines have a positive slope, so that matches that. We can see that right off. We also see over here that that when this is negative over here, look, well, that matches this idea where this graph is decreasing. Okay, so first off, maybe we observe that this matches what it should in this graph, okay, from here to here. But does it give us any information if we jump all the way to this graph over here? Well, in the picture, actually, you'll notice something. See this 0. So this is at the x value 0. And let's take a look at the x value 0 here. Now maybe we don't know this at first, but let's use this as an example for the future to know what this might mean. When x is 0, notice what happens. The graph looks like this, so it's kind of like a downward parabola. Then all of a sudden it shifts to be like an upward parabola. You notice that? There's like a point of changing right there. Now it's like an upward smile or parabola, right? When the second derivative is positive, the output's positive. This is the slope, but the slope is positive. And over here, this is like kind of a downward frowny face, right? When the slope of the slope, meaning the second derivative, is negative. Does that mean anything? Well, let's think about this for a minute. Slope of slope. Well, what is the slope doing? The slope is like this. It's fairly steep. It's positive. It's positive, less positive, less positive, less positive. It's 0. A little negative, negative, more negative, more negative, more negative. It's going down. So notice how the slope's going down? A picture of slope going down. So slope going down means if the slope starts at being positive, it's going to kind of go closer to 0 slope. And then it could even keep going down and go negative slope. So it could go from positive slope to negative slope. That's precisely what negative slope of slope means. It means the slope's decreasing. Slope going down. Slope going down is like a picture of a frowny face. Okay, because the slope's going down, I guess. Okay, but what about, okay, and then it's just opposite if slope's going up. So right here, the slope's going up. Think about this. So the slope starts out negative, becomes less negative, from 0, then positive. So if you go from negative slope to positive slope, that's like a smiley face. Happy smile. So that is, so from the second derivative itself, we end up seeing, if we look at where it's positive, we can expect kind of an upward smiley type effect. And when it's negative, you get a downward effect. So kind of the second derivative or the slope of the slope kind of gives us the mood. And the first derivative just gives us the actual slope if we're going up or down. Are we going up or down? And then how are we going up or down? What's the mood of that process of going up or down? Is it a smile or a frown? In particular, I'm using those words a little flippantly, but the smile part that's usually called concave up. And the frown portion, that's usually called concave down. So from the first derivative, you get where it's going up, then down, then up. And for the second derivative, you get where is it concave down? Where is it concave up? And this is a very good picture. This point of changing actually has a name where it changes concavity. That's called a point of inflection, kind of where the graph kind of inflects. Now, in other videos, we'll discuss these ideas a little bit more, but this is a first example to get us started. Thanks for watching.